All right, welcome back. We're going to go ahead and get started on the definitions on the back side of this page. The first definition that we have here is conjecture, and we're going to say a conjecture is an educated guess. So it's something that you're kind of taking a guess, you're using some information available, and you're coming up with a guess as to what you think is true. Second definition, perpendicular lines. So the definition for perpendicular lines is two lines that intersect to form a right angle. And by right angle, we mean a 90-degree angle. There's a symbol that we use for perpendicular in geometry. It's going to look like an upside down capital T. That's a symbol for perpendicular. And over here to the side, we're going to draw a diagram of what you might expect to see when you see perpendicular lines. So we're going to draw two lines that are crossing, one vertical, one horizontal. And we're going to put a symbol in the corner here, this little box, that's going to represent a 90-degree or a right angle. Statements using this symbol, perpendicular, might look like when we're naming two lines and we want to say they're perpendicular. An example would be something like line AB is perpendicular to line CD. So at any point throughout these notes, if you need to catch up, just go ahead and pause and get caught up, and then you can keep going. All right, so let's talk about parallel. For parallel lines are two coplanar lines that do not intersect. Okay, we have a symbol for parallel, which is two vertical pieces here. So that's going to represent parallel, and we're going to use that in statements. Parallel lines in a diagram are going to be lines that do not intersect. And there are symbols that you may see on these lines. There will be arrows in the middle of the line that will match up. So if we have two arrow symbols here, two arrow symbols here, and that's going to mean that those lines are parallel. If I wanted to write a statement using this parallel symbol, it might look something like this. So if I have lines AB and CD that are parallel, I would say line AB is parallel to line CD. All right, let's take a look at this statement right here. It says, if two coplanar lines are perpendicular to the same line, then, and it's wanting for us to kind of finish that statement. So what we're going to do here, we're going to go ahead and draw a quick diagram. So it says two coplanar lines are perpendicular to the same line. So we're going to start with that same line. And we're going to then add two coplanar lines that are both perpendicular. So here's one line that's perpendicular. And then we're supposed to have two, so here's the second line that's also perpendicular. And what it's asking us to do is to take a look at these two lines and to finish this statement for what their relationship would likely be. And so what we can see here, and kind of an assumption that we can make, is that if these lines are both perpendicular to this original line, their relationship to each other is going to be that the lines are parallel. All right, let's take a look at our next definition here. So the definition of midpoint is going to be the point at the middle of a segment. Okay, in a diagram, I'm going to go ahead and draw segment AB. And I'm going to put a point in the middle. I'm going to call that point M. And then the way that you can show that M is actually in the middle and how you're going to be able to tell from diagrams is that tick mark that we use to show congruent pieces. So if I put a single tick mark between A and M and another one between M and B, that means that segment AM is congruent to segment MB and that M must be in the middle of that segment. Next definition, segment bisector. So a segment bisector is a segment that cuts another segment in half. Okay, so similar diagram to the last one. We're going to start off with a segment AB. I'm going to put a point X right here, and I'm going to put a point in the middle of AB. Call that M. I'm going to go ahead and connect point X to M. And to show that XM is actually cutting through the middle of segment AB, I'm going to add some tick marks here. And I'm going to go ahead and add a statement over here under segment bisector. So XM is the segment bisector. It's cutting this original segment AB into two equal parts, or cutting it in half. So over here I'm going to say segment XM bisects segment AB. All right, a couple more definitions to go. So that was a segment bisector. Now we're going to talk about a specific type of segment bisector. That's a perpendicular bisector. So a perpendicular bisector is going to be a segment bisector that forms a 90-degree angle. Okay, so this is going to be a little bit different than the last one. So we're going to start off with segment AB. And we know that it's going to be a segment bisector, so it's going to go through some midpoint M, which means that these pieces are going to be congruent. So I'm going to add those tick marks. And instead, this time, it's going to be at a 90-degree angle. It's going to form a 90-degree angle. So I'm going to put X right above where M is. And as I connect it to M, I'm going to add a 90-degree angle. So it's still a segment bisector, but it's a perpendicular bisector because it's intersecting it at a 90-degree angle. All right, last definition here is angle bisector. So kind of like a perpendicular bisector cuts it in half at a 90-degree angle, or a segment bisector cuts another segment in half. An angle bisector is going to be a segment that cuts an angle in half. So what we're going to go ahead and do, we're going to start off with an angle here. And I'm actually going to draw a right angle. And I'm going to make this angle into angle ABC. I'm going to put a 90-degree mark right there. Right through the middle from B, I'm going to cut the angle and I'm going to add a point X. So this segment that goes down the middle is an angle bisector. And if I want to show that it's an angle bisector, if this was a 90-degree angle, then each one of these smaller angles is now going to be half of 95 or half of 90 degrees. So this angle and this angle are both going to be 45 degrees. So again, segment bisector cuts a segment in half, angle bisector cuts an angle in half. So those are the last concepts there. Let's talk about these three statements at the bottom of the page. So here we have some statements that they'd like for us to finish. The first one says the distances from a point on the perpendicular bisector to the endpoints of a segment are blank. So this has to do with the perpendicular bisector. So we're going to look at our definition here in the diagram for perpendicular bisector. Basically, it's saying any point that's on this perpendicular bisector, how far will it be to either endpoint, or how will those distances compare? And even if we just look at where point X is, and we compare the distance from X to A and from X to B, I think we can see, or we can at least take a guess that that distance from X to A and X to B is going to be a congruent distance. It's going to be equal. And then the second one here is kind of a similar question. It says the distances from a point on the angle bisector to the sides of the angle. And so on this angle bisector, they're saying any point on the angle bisector, and we're going to talk about point X. How far will it be to A, and how far will it be to C? How will those distances compare? And once again here, we can see, or at least take a guess here, that it looks like the distance from X to A and the distance from X to C are going to be equal, because this is right down the middle. It's splitting it into 2 equal halves. So the distances from a point on the angle bisector to the sides of the angle are also going to be congruent distances. All right, for this last statement here, it says, is it possible to have two lines that do not intersect, that are not parallel? So we've kind of gone over a little bit of this. We know that lines can either intersect, and then today we've talked about lines that are going to be parallel. Okay, those are coplanar lines that don't intersect. But there's actually a third type of line. So the third relationship, and I'm going to kind of try to show you here with these two markers. So we have that the lines could intersect, we have that the lines could be parallel, but the third relationship is that they could be like this. So I think you can see that these lines are not intersecting, but they're also not parallel. And so there's a special name that we use for lines like this, and that's skew. So is it possible to have two lines that do not intersect, that are not parallel? The answer is yes. The lines could be skew. S-K-E-W. Okay, and again, you can use pencils or pens and just kind of visualize how one of them could be going in this direction, the other one in this direction. They're not going to intersect, but they're definitely not parallel. So hopefully you guys were able to get questions answered from the notes, and then just follow up with us if you have anything that you'd like for us to clarify.